2011 SAE Hybrid and Electric Vehicle Symposium in Anaheim, California. And I'm here with Ian Foley, who's Managing Director of Williams Hybrid Systems, a very interesting new company that started up in Oxfordshire, England. It's a spin-off of the Williams Formula One team. Ian, welcome.
Hi.
Tell us a little bit about the background of Williams Hybrid Systems, where you've come from and what the business plan is.
Right, well the company started as a result of the change in Formula One regulations, so our initial product to develop was a flywheel for the Formula One car. But the intention when we set the company up was always to use motor racing as a development platform, a marketing platform to get the technology out into the real world, and now that's just started to happen.
So KERS was a driver behind Williams.
That's right. It was without the KERS regulations in Formula One, then the company wouldn't have happened. It wouldn't have been formed. But it was always the intention from day one to use that as a platform to develop systems for the wider world.
Now you're using a flywheel energy storage system that, to my memory, has been used in aerospace with powered satellites, etc. There's been other companies that have investigated this. A flywheel spinning in a closed housing in a vacuum at up to 40,000 RPM. Is that correct?
That's correct. Yes.
And why is that kind of an ideal storage system for particularly racing technology?
In the racing application particularly, it was all about high power cycling, and that's where the flywheel is absolutely ideal for under high power cycling. There's no degradation of performance for over 1 million cycles, and our particular flywheel technology has got a unique patented technology called magnetic loading composite, where we put the magnetic powder within the resin, and that means we have no losses in the rotor. As the rotor's spinning in a vacuum, if it did have any losses, that would generate heat and you can't get the heat out. So with our particular flywheel, we can continuously cycle that all day long with no loss of performance. That's what's particularly suited to these high power cycling applications.
So Williams' composite experience is playing into the technology development of the flywheel systems.
Yeah, there's a lot of very experienced composites engineers at Williams that we draw on for assistance, but the actual core technology was developed in the nuclear industry. And we acquired that technology from the nuclear industry. So the background to our technologies had about 15 years of development prior to us starting work on it.
So the Hybrid Systems facility is on the Williams F1 campus, so to speak.
That's correct. Yeah. We've got Williams Hybrid Powers now is up to about 17 people, and we're gradually taking over the Williams F1 campus. Yeah.
Now, talk to me about some of the challenges in developing this technology. There's sealing issues. You need real special bearings for flywheel systems. So if you can talk about that.
That's right. Well, for our technology, because we are electromagnetically coupled, all the sealing issues are quite straightforward. So we just use straightforward O-ring seals, and we don't have to have any rotating shafts coming out of the vacuum space. So that's not a problem for us. But you're absolutely right. Bearing technology is really key. We're using the latest development in ceramic ball bearings running in a vacuum grease, and that's really an enabling technology to enable us to run the way we do.
Is the bearing development coming from within Williams Hybrid Systems, or are you working with specialists in that regard?
No, we work with a couple of bearing manufacturers, so that's really their core knowledge that we're using. So we're reliant on them for that.
Now, you've had a close relationship with Porsche and their sports racing department. The new 918 RSR Spider, beautiful car. Perhaps the real beauty is inside when you see inside the cockpit, and next to the driver's seat is the Williams Hybrid Systems flywheel. Tell me about working with Porsche's race group in developing this.
It's been a really positive experience. They came up with a really demanding application, so that they worked out they wanted 120 kilowatt with a 40% duty cycle energy store.
Pretty aggressive.
Very aggressive, and they worked out that flywheel was the way to go, and then went around looking for a flywheel supplier. So we were delighted they chose us for that project, and it was a very tight timescale. I think from signing the contract to the car running was about 7 or 8 months, and then we did a 24-hour race about 4 months after that. So it was a very tight time frame, but with a great group of racing engineers at Porsche.
And that's got to be kind of a really secret to Williams Hybrid Systems' success so far is the racing ethic is in product development.
Absolutely, and I think that's where I think Porsche also have a separate racing division which is able to make quick decisions and move very quickly. Similarly with Williams, that's obviously part of the original core team of Williams Hybrid Power were all ex-racing engineers, and that's enabled us to do very, very quick development. And now our challenge is actually we're bringing in people who are from mainstream automotive to do the productionization phase to actually get us out into production.
Now, looking at hybrid systems in automobiles, Chrysler played with it back in the mid-90s, really didn't go anywhere. You guys are working on it. Is it safe to say that flywheel energy storage is primarily a racing technology moving forward, or do you have plans for kind of volume production solutions in this regard?
No, we have an awful lot of interest now from a number of OEMs in Europe looking at potentially replacing the chemical battery in a mild hybrid vehicle with the flywheel. And the two big benefits are, one is cost. The manufacturing techniques used are all standard automotive, it's the known automotive manufacturing techniques, castings, forgings, etc. And also the power cycling ability. So we can actually have something which potentially is cheaper than a chemical battery but gives a higher power as well, which enables them to make a more powerful hybrid vehicle.
So you're making a case for really good power density and other packaging efficiencies as well?
Yeah, absolutely. The package is smaller than the existing hybrid battery package, and also with it being we call it a mechanical battery. It can be located anywhere on the vehicle, and these are all attractive features for the OEMs.
How about thermal management, Ian? Tell me about that with the hybrid system.
Right, well at the moment, with the very high performance version we've got on the Porsche, it's got there's a separate cooling system, so we're directly cooling the stator of the flywheel with transformer oil, basically.
Interesting.
But something like an automotive application where the duty cycle is so much less, then we can get rid of that and we can have a much simpler cooling system which will integrate into the vehicle's existing cooling system.
Very interesting. Looking at 2011, 2012, what are your short-term goals, business goals, technology goals for the company?
Well, business goal-wise, we're very close, we believe, to signing our first low-volume customer. So we're currently gearing up and doing design validation testing on a productionized system, and we hope to be supplying in low hundreds a year from sometime next year onwards. And that's one of our main focuses. We've got our ongoing racing program with Porsche, which is really then pushing the technological boundaries of the technology, and so we've got those two programs going in parallel.
Very interesting. Thanks so much for talking with us. I really, best of luck for the development of your company. It sounds really interesting.
Thank you very much.
Appreciate it. Thank you.